Good day. Today we will going to continue on what we have discussed last time. Okay, so we have here our specific objective. So you are expected to describe the possible causes of plate movement. Okay, now last time we have seen this video, right? Okay, now. We will going to discuss the two types of forces, and those are driving force, which means either push the tectonic plates toward one another or pull them apart. The second one is the resisting force, or also known as forces act against the driving force of the plate tectonics. And heat and gravity are fundamental to the process of plate movements. Now, as we go through our discussion today, we will going to learn why do heat and gravity are fundamental to the process of plate movement, and we will going to learn more about this driving force and resisting force. Now, let's move on. So, I have here the definition of the driving force. W- I mean, the list of the driving force. So here are they. So we have here the mantle convection, slab pull, slab suction, and ridge push. Now, what is driving force, Mom? When we say driving force, it is wherein the plates, okay, was pushed towards one another or pull them apart. Now let's know one by one what are those. Okay, we have here first the mantle convection. So we have discussed this from the very start, right? So mantle convection is caused by the rising of the heat from one core toward the mantle, and convection currents drive the plates away from one another, and heat dissipates and creates a convection current. Now, we all know what is mantle convection, right? Wherein the hot particles tends to go up and then the cold particles tends to go down. What that is convection. If that happens inside the layers of the earth, specifically in the mantle. That is why we called it mantle convection. Now, this mantle convection or this convection creates a circulation, right, in where hot particles tends to go up, cold particles tends to go down, and it repeat. Now it creates a cycle or circular motion. That circular motion, okay, creates a convection current. Now, this convection current is the one who drives the plate away from another, bump into each other, or pass through each other. Okay, so the reason why do plates move is because of this convection currents created by the mantle convection. Okay, so created by the convection in the mantle. So let's move on. So as you can see here, we have a slab pull, this one, the blue one. Okay, if you have recalled to in the video presented, there is a slab pull two there. Okay, so when we say slab pull, it takes place when subducting slab sinks into the hot mantle because of the difference in the temperature. Yes, because diba, in the mantle convection, the hot particles tends to go up because of the buoyancy, and then the cold particles tends to go down. Okay, that is in the convection, and then this convection creates a convection currents. Now, this convection currents influences the movement of the plates, right? So, this mantle convection also influences the occurrence of the slab pull. Okay, this one is a force that pulls down the oceanic crust down to the mantle, okay, or push down the oceanic crust down to the mantle, and the rest of the plate to which the slab is attached to is pulled in as well. Okay, that is a slab pull. If you have seen here, okay, the slab pull is pulling the oceanic crust towards the mantle. Now we have here the red one, and that is also known as the ridge push. Now, This ridge push occurs when the lithosphere is pushed up by the asthenosphere. Okay, and because of the convection currents from the mantle, if you have recalled about the seafloor spreading in where two oceanic crusts move away from one another, and that creates a divergent plate boundary, right? Now in the seafloor spreading, diba, as the plates move away from one another, the magma will rise up in the rift valley, and as it reaches the ridge, okay, it cools down and it creates a new crust. Okay, so this new crust, okay, can be found near at the ridge, and as time goes by, as the mantle convection continuously creating a circular motion, and the ridge push, okay, pushing the plates away from the mantle, okay, and yeah, and there will be a new occurrence of a new crust near at the ridge. So this one, the one who is pushing, is the ridge push. Okay, it pushes the crust away from the ridge. Okay, now this one also influences the movement of plates, because as it pushed down, in another hand, the slab pull is pulling it down towards the mantle. Now gravity pushes the plate down, and the ridge push, and the new crust is formed. Okay, this one is in relation with the seafloor spreading. As the gravity pushes the plate down the ridge, okay, the magma will rise up and it creates a new crust, okay, that is in the seafloor spreading. Okay, so um third one, we have a slab suction. This one is slab suction occurs when a subducting slab drives flow in the lower mantle by exerting additional force down in the direction of the mantle's convection current. Now this one, diba, um, as the plates moving towards the mantle, okay, there will be an slab suction, okay, from the lower mantle slabs that exerts additional force to drives the plate towards the mantle. Okay, that is a slab suction. Now this flow exerts a shear tractions on the base of nearby plates. Okay, now second one, we have this resisting force, right? We have driving force. Now all driving force are the mantle convection. Let's recall what are those: mantle convection, slab suction, ridge push, and um slab pull. Okay, those are the four driving forces. Now let's discuss those four resisting forces. When we say resisting forces, it acts against the driving forces of the plate tectonics. Now in relation with in a real life situation, this resisting force is like a contrabida. Okay, so this resisting force resists all the forces that created by the driving force. Now let's learn what are those. We have first the slab resistance. Now this slab resistance for is the force that resists all the forces associated with the plate movement, including the subduction zone. Now, diba, in the slab pull, okay, in the slab pull, this slab pull force drives the plates towards the mantle, right? It is pulling the plates towards the mantle, and then as it goes down, there will be a slab resistance that resists all the forces created by the slab pull. Now it pushes back away the oceanic crust to it tries to pushes back away all the oceanic crust towards the mantle. So this one resists all the movements created by the slab pull. Okay, and then we have this collisional resistance, diba, as a plates collide, okay, there is a huge possibility that these plates will subduct, right? Like what happened here. Okay, so um the as the plates, okay, as the plates subducting, there is a collisional resistance. Now, this occurs when a heavy plate, okay, when a heavy plate into the mantle but resists subduction because of the friction. Now, resists all the subduction because of the friction created by the slab pull. Now, this one opposes the slab pull, okay, the collisional resistance, and then the transform fault resistance. Now, we all know what is transform plate boundary, right? We have those three. First is the convergent, wherein two plates can collide towards each other, and then divergent, wherein two plates move away one another, and then the last one is the transform fault boundary, wherein two plates pass through each other. That is a transform fault boundary. Now, this transform fault boundary, okay, is a frictional force due to the opposing movement of the plates moving the past one another between two spreading centers. Okay. Now, it resists the movement or creation of the transform fault boundary. Now, let's move on. We have the last one, the drag force. When we say drag force, it resists all the lithospheric plates. Again, it resists all the movement in the lithospheric plates. Now, what are those in the lithosphere? Those are the crust, including the plate boundaries. So it resists the movement of the plate boundaries. Okay. Now, this four, which are the drag force, slab resistance, collisional resistance, and transform fault resistance, resist all the movements created by the driving force. Now, these two, okay, in overall, so driving force and resisting forces influences the movement of tectonic plates. We have known that mantle convection and the seafloor spreading influences the movement of plate tectonics, right? So those are the big pictures. Now, if we go into a detailed one, this driving forces and resisting forces influences the movement of tectonic plates. Okay, so they are the one who is responsible why do plates move. Okay, so in overall, change is constant, right? We all experience this different kind of changes, maybe in a good one or in a bad one. So the earth itself has its own undergoing its own changes too. So it includes the movement of the tectonic plates. But let us all remember that even though we have been through a lot of difficulties, maybe, and there are huge changes happens into our life, maybe a good one or a bad one. Okay, let's don't forget to thanks God for all those experiences that we have experienced. Okay, because I do believe that in every experience we have experienced, we will going to learn something. I think that would be all for today. Before I will end up here, allow me to share your um, activity that you need to do. Okay, so as we finish this one, so yeah, here, as you can see here, I have this activity of yours, which is activity to diagnose me, in wherein you are asked to analyze and enumerate the possible causes of plate movements. Okay, and then those are, okay, the causes and effects. So in this causes, you may write slab pull, slab pull, ridge push, mantle convection. It's up to you. You may write all of them. Like the one we have discussed in the driving forces and the resisting forces, and you may include the mantle convection and the seafloor spreading, and you will write it down, the effect. Okay, so I think that would be all for today. I hope that you've learned a lot. And for additional information, you may look for your book on page 13, The Mechanisms of Plate Tectonics. Okay, I think that would be all. Thank you and God bless. Bye.